Okay, so I've been working on a full stack application, and right now the full stack application does not have authentication. So that means pretty much anyone can have access to our backend. So right now I want to be able to add authentication so that only authenticated users can have access to them. In my project, I don't want to store passwords in the database. So from my understanding, what I can do is I can use this oauth2 protocol. And in this case, specifically, I can use the Google oauth2 protocol to authenticate the users. So what's going to happen now is my front-end application is going to sign in with Google, and then Google is going to redirect it back to our front-end application once the sign-in is successful. So one thing I was a bit confused is that oauth2, according to the specification, it's only used for authorization and not authentication. If this is the case, then why is it that there's so many websites using oauth2 to sign in with Google, sign in with Facebook, sign in with Twitter? So from a bit more research, it looks like with oauth2 itself, this is authorization. But on top of oauth2, there is another protocol called openid connect. So with these two combined, we're able to use Google, Facebook, or any other website to authenticate the user and also use it as authorization framework. It's just that when we talk about oauth2 nowadays, I believe by default, openid connect is part of oauth2. And this is why that pretty much all the websites has the sign in with Google, Facebook buttons. Okay, so now that we understand why we can use oauth2 as authentication, now let's talk about different ways to authenticate the user. So from my understanding, oauth2 has a few different ways to get the access token from the authorization server, in this case Google. One way is called implicit flow or implicit grant. Another way is called the authorization code flow. So with implicit flow, in this case, when we sign in with Google, Google is going to return us an access token back to our front end. So with implicit flow, I believe it is only recommended to use it with a single page application, since in the implicit flow, the refresh token is not returned to us, only the access token is returned to the front end. So pretty much you will use the implicit flow when your application doesn't require a backend. However, since 2018 or 2019, it is no longer recommended to use the implicit flow. And the reason for that is because it's possible for a hacker to steal your access token. And then the hacker is able to use this access token to basically fetch resources on your behalf. Since oauth2 is an authorization framework, so as long as you have a valid access token, then you're able to fetch resources on Google. So basically, to avoid this, we can not expose the access token in the front end. And in this case, we will be using the authorization code flow. And that's what oauth2 is recommend people to use, which is the authorization code flow. So in this case, you will have a backend where you will still sign in with Google on your front end website, but this time in the when you make the request to sign in with Google, you will have specified the grant type, and that type is called the code. Once you are able to successfully sign in, Google will be able to return back a code, and this code is just a sequence of letters and numbers. Once you have this code, your front-end application can send this code to the backend, and then the backend is able to send this code to the authorization server, in this case Google, in exchange for the access token and the refresh token. Once you do this, then now your backend application will have the access and refresh token. From here, we can establish a session with the front end to indicate that this session is alive, and the request coming in with the session data will be used to indicate that the user is authenticated. So in this case, if we do use session data, then that means we're going to be storing the session data in the backend. So most likely we'll have database where we will use that to store our session data. So I think for most of the use cases, we'll most likely use this approach. However, if we do use this approach, one thing to think about is how to scale this, just from my research, there's a lot of back and forth online between whether if you should use session to authenticate a user or if you should use JWTs to authenticate a user so that your application could be stateless. And the reason that people don't like to use session data is people were saying that if you have a lot of traffic, say if you have millions of users, then that means you're going to have a very heavy read on your database, and that's going to be expensive. So in order to avoid this, you can use JWT so that you don't have to read into the database to figure out if your user is authenticated or not. However, like I said, right, if you scale it to millions of users, then this might be an issue. But for most of the applications out there, you're not going to have millions of users. We're not Facebook or Google. So I believe like session data is probably the right way for most of the applications. So let's assume that we're using JWT instead to authenticate user. So what this means is that when the access token and refresh token is returned back to us, this access token will be in the JWT form, right? Then what we can do is we can send this access token to the front end. And then every time when the front end makes a request to the back end, we will set the access token in the header. And then the back end application will basically check the header to make sure the access token is valid. If it's valid, then we're able to return data. So technically, this arrow is this way, and then the data will be coming back to the front end with a 200 OK. So in this case here, since we're using JWT tokens, the backend no longer needs to reach for the database. It's no longer need to reach for the database to check if the user is authenticated or not. However, since we're using JWT tokens, that means if your token is leaked, then there is no way to invalidate that token. So one thing that you need to think about is how are you going to invalidate the tokens? From my research, people are saying that you should keep a list of tokens in your database to keep track of which ones are invalid, right? So that means that the access token, here, I'll move this back. Then in this case, we'll have access tokens in the database, a list of them, right? We'll have a list of tokens in the database to keep track of which one is valid and which one's not. But now the issue is this kind of defeats the purpose of having JWTs, since the reason we want JWTs is so that we don't have to reach for the database. But in order to keep our web application secure, we probably want to keep track of which tokens are valid and which tokens are not. And to do that, we have to store the tokens somewhere to check. So that's kind of like a debate whether you should even use JWT to begin with. So I guess the point I'm trying to say is that there are pros and cons with access token or session authentication. I don't think there's like right way. It all depends on what fits your application. If we're using the authorization code flow, let's go back to the authorization code flow with OAuth. Move that authorization code flow. Since we're still getting the code from Google and this code is still exposed in the front end, that means the hacker is still able to steal your code and then use that to exchange the refresh token and access token. One thing to do to prevent that is to use this thing called PKCE. This stands for proof key for code exchange. So what this means is that we're going to generate a code challenge, also a challenge method. Then this is going to be sent to the authorization server when we sign in with Google or Facebook. So once we send this to Google, then that means Google will have these information. So now when we get the code back in the front end and when we try to send this to the back end here, so we can exchange the access and refresh token from the authorization server here. So basically this goes here and then this goes to Google again. When we send this code, we're also going to send the verifier to the authorization server. And this verifier is coming from our front end. And this verifier is used to generate the challenge and the challenge method at the very beginning. So now that we're sending the verifier to the backend, and then the backend will send the code and the verifier to Google, then Google will use the challenge method to validate the verifier to make sure that this is the same as the challenge that Google received at the beginning. So making sure this right here, it's going to equal the challenge. If this is true, then that means Google will send the access and refresh token to the backend. Imagine the hacker has the code and they're trying to send this to the backend so that it can exchange the access and refresh token with our server. But because the hacker doesn't have the correct verifier, and that means Google won't be able to verify that this request is from a trusted source. Then in that case, the validation will fail. Therefore, nothing will get returned back to the hacker. So this pretty much reduces the risk in your web application. Yeah, that's it for this video. Thanks for watching.